All right, and should be recording. Cool. Exercise 4B, determining equations. So 4B is determining an equation. In your textbook, they usually give you a whole bunch of rules. For example, here, these are the different types of models that you can have for quadratic. I normally like to simplify it down to just 3 basic ideas that you need to look for. So, whilst you can memorize that, you can memorize that, and you can memorize these two, technically, these two are the same things. One has transformations and one doesn't. They're both turning point form. Yeah, it's something squared. There's only one x. There's a dilation factor. This one doesn't have a k movement and doesn't have a h movement. This one does. So you only need to memorize the turning point form, yeah, or understand transformations. This one is pretty much similar to this in the sense that it's about factorizing. Take out the x as a common factor, means that there is a solution on x equals 0. And then what's different? This one. That's the general form. This one we generally don't like using because there are 3 parameters that you'll need to find, which makes it harder. So they have to give you 3 pieces of information. The others, they'll give you key information. So your ability in this exercise is to determine what are key features that I can see that helps me determine the equation, right? So I try to help you down here. I think you only need to know 3 key distinct equations. Here are your 3. When there are no x-intercepts, so they haven't given you anything, your general equation is likely the bet to go. So they'll give you an equation where there's no x-intercept, so you can't even do any factorized form, and there's no turning point, so hence you can't even use a turning point form. That's your best bet. Next one, if they give you a 1 x-intercept or a turning point, right? So then you should already be thinking, well, 1 x-intercept means that you can only have 1 linear factor, which means 1 bracket. Whereas when you factorize into 2 brackets, means there's potential 2 x-intercepts. So when there's only 1 bracket, well, that is of this form. This has 1 bracket. So if they gave you a turning point, you can find h and k straight away. But if they gave you only 1 x-intercept, you can find h straight away as well. Okay, so it has to be a tangent to the x-axis. And then finally, the other form that you have is 2 x-intercepts. So in the graph, they might already give you 2 x-intercepts, so you can see that it crosses. If it does, well, the only way to have 2 x-intercepts is that it has to be 2 linear factors. So hence, you expect something like x plus d, x plus e, and then there's a dilation factor at the front. Remember, that's the dilation factor from the x-axis, meaning affecting the y values, right? So those are the only 3 I usually just think about. And if you understand those 3 key ideas, you can do it the same thing for cubics, for quartics, logs, and exponential, because you just look for the key features, okay? So let's do some examples. So look at the graph and determine how many x-intercepts they normally give you. That's because x-intercepts, that means you can factorize them. So that's what I usually look for polynomials. So let's look at the first one. So looking at 3, I'm just going to zoom out a bit so you can see the table. Let's look at the first one. A. What things have they given us? Give me one piece of information that you can see. Let's go, Ryan. What do you see? Very good. They've given you an x-intercept at 0, 0. So you've got x-intercept. What else can you take out from this as well? Lockley? There's a point at 2, 5. So they've given you a piece of information, but that doesn't tell me the turning point, and it doesn't tell me the x-intercept. That means just an extra xy coordinate. The other thing that we can take out is the x-intercept happens to also be the turning point. Okay, so hence, we would likely use turning point form. So hence, I would start off by writing the equation out. I'd say, well, it's likely to be of the form a bracket x minus h squared plus k. But if I want the turning point to be at 0, 0, what do we know from that? What can we say about the parameters? What can we already say? Let's go with Dante. Yeah, h and k has to be 0 because those are responsible for left and right and up and down. So I already know h has to be 0, k has to be 0. Well, then that means my equation is a times x squared plus 0. So there's only one parameter left, a. And this is where Lucky was saying, well, we also got the other piece of information, 2, 5. That tells me when x is 2, y is 5. So I can say, oh, well, that means if x is 2, y is meant to be 5. That's a substitution so that I can solve for a. And that gives me now 5 is equal to a times 2 squared. 4a is equal to 5. Therefore, a must equal to what? Can I please have Alex? What's a equal to? 504. It was tough, but you made it. So you got a equals 504. So that means my equation for this one, determining the equation, must be y is equal to 514 bracket, well, you don't have to write brackets because there's no movement, so it's 514x squared. Okay, so you got the dilation. Let's do the next one. Serena, name me a feature that you can see in part B. You can see the turning point is at 0, 3. Very good. You got turning point, so you got a turning point, 0, 3. And I guess in this scenario here, funny enough, I should have picked a different graph. This actually is very much similar to what we just did. So in this case, same thing again. Y equals a bracket x minus h squared plus k. What can we say about the parameters? Let's go with Ella. Why knowing the turning point is 0, 3 is going to help me solve this equation? And what would h and k be? Beautiful. So, putting it together, we now have a times x squared plus 3, and that's equal to y, and by the same theory again, they happen to give us another point, negative 3, 1. So, by the same idea, that means when x is negative 3, y needs to be 1. So my equation is 1 is equal to a times negative 3 squared plus 3. 9a plus 3 is equal to 1. Subtract 3 on both sides, you get negative 2. And a must then be negative 2 on 9. Which confirms the shape of the graph. It's inverted. A is a dilation with a reflection. Does that make sense? Flip over to the next page. Okay, so this is essentially the basics of what you're going to be doing. What about example 2 now? So now they don't give you a graph. They give you a sentence. So here I've got a parabola has x-axis intercepts 3 and 4, and it passes through the point 124. Find the rule for this parabola. So what form or what can you deduce from this information? Can I please have, let's go with Tara. Very good. So I've got 2 x-intercepts. The first thing you should be thinking about, well, the only way to get 2 x-intercepts must mean that you have 2 linear factors. Dilation, I don't know. Now, if you're going to have an x-intercept at 3 and an x-intercept at 4, what goes inside the brackets? Let's go with Samuel.
You have x minus 3 and then x minus 4.
Beautiful. Okay, so that rids of all 2 parameters there. So you only got 1 more parameter to do, and that's why they gave you this extra point. That when x is 1, y is 24. Alrighty, let's work this one out. So it should be 124. So here we go. When x is 1, y should be 24. 24 is equal to a times 1 take away 3 is negative 2. 1 take away 4 is negative 3. So together 6a is equal to 24, and therefore a must equal to 24 on 6, which is 4. That gives my equation as 4 bracket x minus 3 times x minus 4. So far, pretty straightforward. Pretty good. Let's try the last one. Now, the last one, depending on which exam, Sometimes they put this in exam 1. It does mean that you need to know how to do it simultaneously with 3 points. Okay, so if you want to do it by hand, if it's in exam 2, you plug it into the CAS and you can get it as well. Can I get a show of hands who know how to do this on a CAS? Define parameters ABC. Okay, cool. So maybe half of you don't. I'll show you. So this one, they tell you it passes through these points, but they didn't tell you whether it's x-intercept or y-intercept. In this case, I can see there's a y-intercept there. But we know that it has to be y equals ax squared plus bx plus c, because they didn't give us a turning point. No x-axis intercepts. But just even looking at the coordinates, can you see 0, 5? Why is 0, 5 special? Pat? Very good. Because if x was going to be 0, these will cancel out, and then y is going to be 5. Well, then that means c equals 5 straight off the bat. Okay, so looking for y-intercepts or x-intercepts will help you figure out some parts of the terms. Let's do this by hand. So let's see if I said sub 0, 5, you should have, therefore, c is equal to 5. Your equation now is ax squared plus bx plus 5. And now you've got the other 2 points to work with. So let's sub it in. If I substitute it in 1, 4, I will then get 4 is equal to a times 1 squared plus b times 1 plus 5. Simplifying that, minus 5 on both sides, that gives me minus 1 is equal to a plus b. That's equation 1. Let's do the same for the second point. The second point that I can have here is clearly negative 1, 10. So if x was negative 1, y is 10. You will now have 10 is equal to a times negative 1 squared plus b times negative 1 plus 5. Do all this in one step. So that should give you now 5 is equal to a minus b. That's my second equation. And then I'm assuming that you've done your chapter 2 holiday work and your chapter 1 stuff is pretty okay. So simultaneous equations. You have negative 1 equals a plus b, and you have equation 2, which is 5 equals a minus b. What method would you use to solve a and b? Can I please have Neil? That's true too. Yep. Elimination method. So elimination method, we can see that as long as the values of the parameters are the same, then you can subtract or add. In our case, we're subtracting. So we do that. Negative 1 minus 5 gives me negative 6. A take away a is 0. B take away a negative b becomes positive 2b. So 2b is equal to negative 6. Therefore, b must equal to negative 3. To find a, well, you got the 2 equations there. Choose which one that's easier to do. I would sub it into the first one. So negative 1 is equal to a plus a negative 3. So that means a must be negative 1 plus 3. And a is equal to 2. Let's do this on a CAS. For those who don't know how to do it on a CAS, there's maybe 2 or 3 ways to do it. And if you have other programs, it might even be 4th way. This is how I do it. Go on my CAS. I was just showing my year 11s how to do simultaneous equations here. So same idea. Go to your calculator set, page, menu, algebra, which is number 3. So you go menu 3 and then solve, which is number 1. So press menu 3, 1. So on the pad, press menu 3, 1. You get solve. And what I like using is the frequently used button. So next to the catalog or next to the 9, there's a button that is your frequently used apps, whatever it is. Yeah. Simultaneous equations, you've got 2 or 3 or more. So if you have 3 or more, you can use that one there. If you have domains, then these are the other 2 that you can use. So in my case, I'm not looking for domains, and I only got 2, so I'm going to stick with this one. So this is my format, and Am I doing 2? What am I doing again? No, I've got 3. What am I talking about? Oh yeah, I do have 2. That's right, because we already worked out the intercept. So A plus, no, what was it again? -1 equals A plus B. And the other one is 5 equals A plus minus B. Is that right? Yes. Make sure to move the cursor across, comma A, comma B. Close brackets. And we've got 2B -3. But let's say you did it all in one go and you didn't realize there was a y-intercept. Then the other way I normally like to do is I like to define the function first. I would have done menu 1, 1. Define the function as a times x squared plus b times x plus c. Be careful, if you just write bx, they won't know the difference between bx and b times x. So if you don't put the times in between, it won't know that a and b are different terms or coefficients. Okay, so you must put in the times. After I define it, I do the same thing again. Menu 3, 1. And I'm solving. Now there are 3 equations. So I'm going to go to this one because there are 3 points they've given us. They told you that when x is 0, so f of 0, y value is 5. Next one, what do they say? When it's 1, it's 4. So f of 1 should equal to 4. And f of, I think it was -1. Yep, -1 is equal to 10. So this is one of the reasons why I like to define it first. It means I don't have to type it all again. Just define it once. F of 0, so that's x0, y5, x1, y4, x -1, y10. And then here I say comma A, comma B, comma C. Did you get your answers 2, -3, 5? Okay. So that's simultaneous equations for exercise 4B. Pretty easy. Okay, so a lot of it was just defining, finding out determining the equation. And let's pause this video here. I'm going to give you guys maybe, let's make it 15 minutes. And then at 11 a.m., I'll go through the notes for 4C. Just give you a bit of a break until then, okay? So 4C, we'll go through the notes and then we'll move forward. So here we go, 15 minutes of your time. I'm going to finish